Oh, hi. Hi. I just wanted to pop in real quick and talk to you guys a little bit more about our beautiful periodic table of elements. All right. One more thing I kind of want to add in when we talk about reading the periodic table and being able to tell more information by reading this tool, the periodic table. So we've talked about several times already before that the periodic table is a representation of all the different types of atoms that exist. We have 118 that we know of. That's how many boxes there are up here. All right. And I wanted to talk a little bit we've talked about how elements are organized based on their properties. For example, copper and silver are right next to each other. And they're right on next to each other for a reason. They are very similar. They have a lot of similar properties. By properties, I mean they are both shiny, they are both conductive, they are both metals, they're both solids at room temperature, so on and so on and so on. They have a lot of things that are in common with each other. While on the other hand, copper and argon are not next to each other, and that is because they are different from one another. All right? Argon is a gas. It's a little bit more lightweight. It's not very dense. It's not conductive. It's not lustrous, which means shiny. All right. And since they are not very similar to each other, they are far apart from each other. All right. So now that's just an example of how we organize these by their properties. The property that we are going to be focusing on this video clip here is about the different states of matter. All right. Now we know that there are three main states of matter. We know the solid, liquid, gas. All right, there's technically 5, but we're going to focus on the 3 right now: solid, liquid, gas. All right. So we have on my periodic table up here have organized which one of these are solids at room temperature. Room temperature literally meaning about 70 to 75 degrees Fahrenheit, about 20 to 23 degrees Celsius, depending on kind of where you're at. Room temperature is the temperature you are sitting in, probably at this moment watching this video. These properties, some of them will be solids at this room temperature, some of them will be liquids, and some of them will be gases. All right, and we can mark these on here, and eventually we'll update our periodic tables to match that. But my periodic table is kind of nice and kind of fancy, and it does that already. All right, now, the way they do that in my periodic table is by the color of the letters. All right. Now on this board here, you should be able to see that there are actually 3 different colored letters. Clearly there's black, but there's also reds. And then there's actually 2 blues. Now, you'll say, well, what about these ones here that are kind of like block letters that are colorless? We'll talk a little bit more about those in a different video. Those are man-made elements. We'll talk more about those later. All right. Right now we see that there are 3 colors: black, red, and blue. And those are to represent what state of matter those elements are in at room temperature. So the ones lettered with the black letters, those are solids at room temperature. Some of them you're very familiar with: silver, gold, copper, nickel, chrome, or chromium, which is what we use to make chrome, aluminum, which we think of as like aluminum foil, aluminium, tin, as in tin foil. All right, these are all ones that you guys are probably familiar with at room temperature being a solid. Then there are ones that are gases. Those are represented in the red letters. All right. Red letters here, we got oxygen and nitrogen. Those are the 2 main components of the air we breathe. All right, nitrogen gas and oxygen gas, they are a gas, including things like helium, neon, argon, krypton, and including, one always forgets, hydrogen. Hydrogen is the most abundant element in the entire universe. Over about 95% of the universe is made of this one type of atom. Hydrogen is the most simple one, and it is a gas at room temperature. All right. And then there are only 2 elements that are liquid at room temperature. One is mercury. Mercury, you would see these as a silvery metal that is a liquid at room temperature. You would see it in old thermometers. Unfortunately, if it seeps into your skin, it can leach into the blood-brain barrier, get into your brain. It can cause madness. Lots of other, obviously, problems with that. There's also bromine, which you don't deal with too much in your everyday life, but it does exist as a liquid it's almost kind of like a purplish liquid, if I remember correctly, at room temperature. So let's recap real quick. First of all, notice that the ones in black, they are the solids at room temperature. Notice that the vast majority of the elements, especially the metals, are solid at room temperature. Notice that they're all kind of together. You notice that most of the liquid or the gases, which are in red, are kind of over here. They are the non-metals. Right? They are all non-metals. There are a few non-metals like iodine, sulfur, phosphorus, carbon, all right, that are non-metals that are solids, but the majority of them are gases, all right, including hydrogen. And then finally that there are two liquid ones at room temperature. Now I keep saying at room temperature because that's very important. Every element can be at solid or liquid at gas. You can turn gold, which is a solid at room temperature, you heat it up, it can turn it into a liquid. If you put in the right amount of pressure and air pressure and temperature, you can actually turn it into a gas, into a gold vapor. That's how they actually use a lot of things to take gold, like my wedding ring is silver made out of gold. What they do is they take a gold gas, basically, and they spray it on there, all right? And then it cools down back into a solid and gives that nice lining, all right? Every one of these things could be a solid, liquid, or gas given the right circumstances, but at room temperature, most of them are solids, some of them are gases, and only two of them are liquids. Okay, that's all we wanted to talk about today. That was a quick one, and we'll use when we update our periodic tables, we'll include that information. All right, so thank you very much. Good luck, and may the science be with you.